I suddenly think it illuminates what mathematics is today if you have some idea of the history.
There's an incredible authority to how we think about numbers now, and yet there's absolutely nothing inevitable about that way of thinking about numbers.
I don't know too much about the history of mathematics, probably no more than anyone else who has a college education does.
The earliest math, if I'm not mistaken, is that of Babylonian math.
Babylonian is before Greek, right? And the Babylonians were very well known for being wonderful astronomers.
We are speaking about something like 1700 BC or something like that. Before you have the first clay tablets and numbers and all kinds of attempts to solve various practical problems.
Making very, very precise measurements of where the planets or where the heavenly bodies were.
Egyptian mathematics, which is a little bit later and less developed algebraically.
In Egypt, move those things in the pyramids, and look at what comparing that to the buildings today.
I guess that's one of the interesting things about looking back at the history of mathematics. You're like,
They didn't have variables.
I could have gotten my PhD so easily that I'd be famous. Like,
The way to construct right angles is to use a rope and divide it according to ABC, so that A squared plus B squared equals C squared.
I could figure this out. I mean, no, we only can figure it out because it's presented well now. But as a grad student, certainly I do lament the fact that I'm not infinitely older than I am.
I think math usually came from in Rome or Greek.
I probably talked a lot to people about the Greeks.
So we are speaking about 500 BC to about 300 AD.
They imagined geometry as what you could do with making circles and making lines. I mean, they used a compass to make circles and a ruler to make lines.
From there on, this is a golden age of Greek mathematics.
And they were a fish in water in ways they couldn't see.
As you know, the most noted Greek mathematicians of the time, or certainly some of them, were members of Plato's academy.
So part of that is just sort of historical accident that that it just happened that what developed into the modern collection of work of mathematics came mostly from the Western world.
The idea of doing it systematically from axioms and proving things, this is, if you want, it's a philosophically motivated idea that was implemented by mathematicians.
The Greek tradition, who were the ones who happened to most study first come up with the axiomatic formulation.
The whole body of beliefs, for example, our beliefs about the geometric structure of the world, can in fact be seen as depending on a much smaller number of basic fundamental beliefs.
The point is that Euclid gave us an axiomatic method, which is the method employed up to nowadays.
But there was certainly lots that was done in the Arabic and the Chinese world, and like they discovered many of the theorems that we use nowadays.
In Chinese math, I think there is a text from, if I'm not mistaken, 600 AD or something like this, called Math in 9 parts. Okay, and they have a lot of theorems there.
They didn't necessarily prove it in the rigorous way.
The proofs are not really valid, but the algorithms are.
But they did know a lot, and we do still use a lot, and it did contribute.
In particular, the Chinese remainder theorem, which is...
If I have, say, some number of people, like between 1 and 100, and I want to know how many people there are, I can get them to line up in rows of 3, and then I'll get a number of rows of 3, and then there'll be some numbers of people left over. And then get them to line up in rows of 5, and then you'll have some number of people, and then some people left over. And then line them up in rows of 7, and then again there'll be some number of people left over. And I can just count how many people are left over, and that will tell me how many people there were originally.
Has been a big tool in mathematical logic.
And I think maybe that's most, like China is kind of far away, so it didn't contribute necessarily, like at the time travel was very difficult and it didn't contribute so much to the Western development. But the Arabic mathematics definitely has had some pretty obvious impacts.
The Arab mathematicians, they had a lot of algorithms, and actually the very notion of an algorithm, the very name algorithm comes from Al-Khwarizmi, who wrote profusely about this, giving all kinds of algorithms to solve algebraic problems.
Numbers that we use were developed by the Arabic mathematicians, and the names of many mathematical concepts come from Arabic. For instance, the name algebra comes from the name of a particular Arabic mathematician.
Indian, there's a lot of calculations, there's a lot of computing math.
They could do amazingly fine calculations. I mean, as far as I remember, they calculated pi to a lot of what were equivalent. They didn't quite have decimals, but to the equivalent of a lot of decimal places.
We have also a first appreciation of some notion of probabilities, big numbers or something that can be chosen as